Happy day children. Previous class we discussed about force and its types. Today we are going to discuss about two properties of liquids. Before we start the properties of liquids, answer for my questions. Why are raindrops spherical in nature? A liquid flowing out of a very small opening in a tap comes in the form of a fine drop and not as a continuous stream. Why? Trees are greenish. They are greenish at the tip too. How does the water rise upward in a tree or plant against the force of gravity? All the above questions have an answer. It is due to surface tension, which is the property of a liquid at rest. Before we go deep into it, we must have an idea of cohesion and adhesion, which are attractive forces. The attractive forces between the molecules of the same type are called as cohesive forces. And you can see here the molecules of water are attracted by hydrogen bond. That is why you are able to keep liquids in open containers. Attractive forces between the molecules of different types are called as adhesive forces or adhesion. Here the molecule of water are attracted to the walls of the pipe through adhesion, and they are attracted to each other. The water molecules are attracted to each other by a force called as cohesion, and the water molecules are attracted to the walls of the pipe through a force called as adhesion. Consider a beaker filled with water. The water molecule in the center is being attracted in all directions. But if you see the water molecule at the surface, it is being attracted towards the bottom only. Since no water molecules are there above the water molecules on the surface. Since they are attracted downwards, they tend to contract themselves like the molecules of an elastic membrane. See here, you will see the difference in the distance between the molecules. The intermolecular distance reduces. That is, all the molecules are pushed downward and they tend to behave like an elastic membrane. If you place a needle or a paper clip above the water in a beaker, it is balanced by the molecules on the water surface that is now behaving like an elastic membrane. So the needle does not get submerged. Here you can see surface tension is the property of liquids only, not for gases, because you can visualize here gases, they do not have any free surface. The molecules of a liquid experience a force which contracts the extent of their surface area as much as possible, and this property of liquid is called as surface tension. The force exerted on the surface of the liquid is directly proportional to the length, and this symbol of proportionality is removed using a constant called as sigma, which denotes the surface tension. Here you see, since F is equal to sigma into L, we can say sigma can be written as F divided by L. And we can come to a conclusion about the SI unit and CGS unit of surface tension denoted by sigma. So sigma is equal to Newton per meter in SI system and dyne per centimeter in CGS system. Surface tension is a constant for a particular liquid at a particular temperature. Surface tension decreases with an increase in temperature, because as temperature increases, due to the heat produced, the bonds break. Let us now have a look at the real life applications of surface tension. Capillary action. What is capillary action? It is the ability of the liquid to flow in narrow spaces without the assistance of even or in opposition to external forces like gravity. Here, the adhesive forces between the water molecules and the glass is greater than the gravitational force. Water molecules are absorbed by the roots upward due to capillary action, where water molecules show cohesion with each other and adhesion with the walls of the xylem vessels. So you can visualize here that these water molecules, they have a cohesive force between themselves, and there is an adhesive force between the water molecule and the walls of the xylem vessel, which makes it to move upward against gravity. Here the water is being absorbed by the roots and it is taken till the tip of the tree by capillary action, which involves both cohesion and adhesion, and due to which the trees are full of greenery. Here also the phenomenon of capillary action is involved. Here you see, it is the capillary action that the ink is absorbed by the tissues due to adhesion between ink and the tissue paper. Even oil is absorbed by the wick in the same way. So here also surface tension plays a very important role. And you should know that for a given volume, the surface area of a sphere is the minimum. This is the reason for the liquid drops to acquire a spherical shape. Can you name this insect, children? Yes, exactly. You people are correct. It's water strider. This water strider is sliding in water. How is this possible? It is possible due to the surface tension of water, because the topmost layer of the water acts as an elastic membrane. Sailors pour soap water or soap powder. Do you know why? Can you see the ship? It is just about to sink because of the heavy storm in the sea. Now, how do the sailors, they control this? The sailors, they pour soap water or oil into the sea water near their ships to decrease the surface tension of the sea water, because the soap water reduces the hydrogen bonding between the water molecules. This process reduces the impact of the violent water current against the fall of the ship. The ship remains steady like this. Till now, we discussed the property of a liquid at rest, that is surface tension. Now it's time for us to know about a property of a liquid in motion. See the flowing of water, the water flowing. Now look at the honey. Do you find any difference? Yes, there is a lot of difference. Honey shows a resistance to the gradual deformation. See here, water gets deformed very easily, but honey shows a resistance to the gradual deformation, and this can be informally called as thickness. Okay, so now this property, which is nothing but the resistance to gradual deformation, is called as viscosity. And today we are going to have a look at the viscosity, the property of liquid in motion. Imagine a boat moving on water. With boat water molecules on top layer are also moving. As we move deeper and deeper, movement of particles reduces. Since there is an attractive force between the molecules, the deeper molecules try to prevent particles to move with both. And to overcome this force, both needs to apply more force. The force which prevents the relative motion between the layers of liquids is called as the viscous force. And this phenomenon is called as, or this property is called as, viscosity. So, what did we understand from this? That when a liquid is flowing, there is a frictional force between the successive layers of the liquid. This force, which acts in order to oppose the relative motion of the layers, is known as viscous force, and such a property is called as viscosity. Let us try to understand this by an activity. Take a table, spread honey on it, place a plank Let us try to understand this by an activity. Take a table, spread honey on it, place a plank above the honey. It is easy for you to push the plank easily. Is it easy for you, children? No, you can't push the plank very easily. Now, imagine the honey in the form of layers. You will see that your force which is needed to push the plank is more. You have to apply more force. What do you see then? You will see that the molecules on the surface move freely, whereas the molecules at the bottom move very slowly. So, why does this happen? See the molecules on top, they are moving little freely, but the molecules at the bottom layer are moving very slowly. So what do you understand by this? That the force applied here on the plank, you can see the plank, the force being applied on this plank is directly proportional to the area of contact, and it is directly proportional to the velocity of the moving particles, and the force is inversely proportional to the distance between the layers of liquid. So by this you can combine all the three and you can get force is directly proportional to area into velocity divided by distance between the layers. And in order to remove the symbol of proportionality, we replace the symbol of proportionality by a Greek letter called as eta. So force becomes, force is equal to eta into area into velocity divided by distance between the layers. You can say that eta is nothing but the coefficient of viscosity of the fluid. So, what is the SI unit of viscosity? Newton second per meter square, or when you resolve this Newton in terms of kg meter per second square, you will get the unit as kg per meter into second, and the CGS unit of viscosity is poise. How do we get the SI unit? Eta is equal to force into displacement divided by area into velocity. So force, the SI unit is Newton, displacement, the SI unit is meter, divided by area, the SI unit is meter square, and velocity, the SI unit is meter per second. When you solve all this, whatever has to be cancelled, after cancelling the like terms, we get the value as Newton second per meter square. So we get the SI unit of eta, that is coefficient of viscosity or viscosity, as Newton second per meter square. A liquid is said to have more viscosity when strong force of attraction is there between their molecules and there will be less relative movement. And a liquid is said to have more viscosity when weak force of attraction, we can say A liquid is said to have more viscosity when there is a strong force of attraction between the molecules. But when a liquid is said to have less viscosity when weak force of attraction is there between their molecules, and there will be more relative movement. So we can say that engine oil is more viscous and water is less viscous. Let us relate the term viscosity with our real life situations. One of the application is brake fluid. The brake system will not operate properly if it had a different viscosity. The second application is the lubricants. Lubricants also must have a specific viscosity for them to work properly. Now you can know that coolants are used in machining at the lathe shops. So these coolants which are used in machining at the lathe shops must have a specific viscosity. Now the next is petrol. Why it is used as a cleaner? Because it is less viscous than water. Since the viscosity of water is 1, petrol, alcohol, they have viscosity less than water. And honey and other liquids like ghee, they have more viscosity than water. And then you can say that in engineering, by knowing the viscosity of the fluid, engineers can calculate the amount of energy needed and to design the pipes to transport those liquids to various places. So this designing of pipes becomes easier for the engineers when they know the viscosity or the viscous force produced by any liquid. Now let us summarize. What all we learned today? We have learned cohesion, adhesion, surface tension and viscosity. What is cohesion? The force of attraction between like molecules. And what is adhesion? The force of attraction between unlike molecules. What is surface tension? The force acting on the surface of a liquid per unit length is called as surface tension. And what do you mean by viscosity? Finally, viscosity is nothing but the force which prevents relative motion between the layers of liquids is called as viscous force, and this property of the liquid is called as viscosity. Thank you children for listening to my class with great patience. Thank you all.